Okay, so phase shift has to do with horizontally shifting things. And we've already learned how to horizontally shift things. Today, the bell work that we did was an example of horizontally shifting the sine and was it a sine function we were shifting? Yeah, the sine function. And we've already learned how to horizontally shift other functions. For example, do you guys remember if I have f of x equals x squared, if I want to shift it to the right 3, what do I do? Right 3. What would I do to go right 3? What would I do? Think of plus 3? Like this? That would shift it right 3? Wow, that one would shift it up 3. So what do I do to get it to shift to the right 3 units? Not divide by 3. Not times by 3. Huh? Think about our bell work. What did we do? Minus 1/3? No? Do you remember you got to replace inside the function? What would I replace x with? If I want to shift it right 3, I would
X over 3.
replace x with x minus 3. You guys don't remember this stuff? Actually, we did it last year, so it's been a little while. But to shift it right, we replace x with x minus 3. How would I shift it left? 4. Okay? I don't just put plus 4. You guys don't say plus 4. Say replace x with x plus 4, because plus 4 would shift it up 4 units if I just added 4 to it. Does that make sense? So, like if I wanted to go up 4, what would this whole function say? X squared plus 4, like that. Do you see the difference between this one and this one? The last two right here? Study the difference. I want you guys to think about the difference. Okay, this one is going to shift it up 4. This one up here is going to shift it to the left 4. How would I get it to move down 6? Down 6. X squared minus 6. Good. Okay, and so that's how we would shift it down 6. So these are examples of horizontally shifting a function or vertically shifting a function. And we learned that probably at the first of the year last year. Not probably, we did. We learned it in about October last year. Okay, so do you kind of remember that now at all? I can do this with any function. For example, the function f of x equals the absolute value of x. Remember, this is a V shape, and it's at 0, 0. What if I want to move it to up 3? Okay, this is going to be the same thing, so watch this. Okay, watch this. You guys got to stay with me because we got to get going. Okay, if I want to go up 3, what do I do? Okay, I go f of x equals what? Tell me what to write. What's my function? So the absolute value of x plus 3. That moves it up 3. What about down 2? Okay, the absolute value of x minus 2. How about right 1? Replace x with x minus 1. Whoops. No, it's x minus 1 would move it right 1. Remember, horizontal shifts are in the opposite direction of the sign. Okay? How would I go left 7? Left 7. Replace x with x plus 7. That's how I move it left 7. Okay? Any questions on that? Okay? That's horizontally shifting or vertically shifting something. Now, going back to phase shift. I'm going to give you the definition of phase shift. If you are given y equals capital A times sine of k theta minus c, for y equals capital A times cosine of k theta minus c. The phase shift is c divided by k, where k is greater than 0. In other words, k has to be a positive number. If it's a negative number, then it works opposite from what I'm showing you. But and if c is less than 0, then the shift is left. If c is greater than 0, then the shift is right. Now, just a second ago, we talked about this thing going in the opposite direction of the sign. But notice right here that right here in these two things, this is a minus sign, right? So if I put a negative number in for c, like -4, that would be minus a -4, which would be +4, right? And that's why it appears to be in the opposite direction. The main thing you need to understand right here is this right here. Phase shift is c divided by k. Got it? So if I gave you an example, y equals 2 cosine of 3 theta minus 4, what would the phase shift be? Okay, what would, look in the definition up here. Here's c, here's k. Okay, is it 4 over 3 or negative 4 over 3? It's 4 over 3 because look, the definition gives a minus sign right there, and there's a minus sign, so that's a positive 4. So it's positive 4 divided by 3. Now, if that would have said 3 theta plus 4, so let's say I gave you another one, 2 cosine of 3 theta plus 4, that one would be negative 4/3. Do we understand that? All it is taking the number right here, where the c is, which is 4, and dividing by the number in front of the theta, which is k, so 4/3. And that's going to give you your phase shift. That's how far it's going to shift left or right. Does that make sense? So everybody write down for phase shift, how far it will shift left or right. How far it shifts horizontally. Okay, that is called the phase shift. Now, let me ask you this. What is the amplitude of these two functions down here, you guys? Okay, the amplitude is 2. That means it's going to go up to 2 and down to -2. What is the period of this sine function? What's the period of this sine function? Not 3. How did you find period? I gave you a formula for period last time. What was it? Period equals? That's right. 2 pi over k. What's k? So, yeah, k is 3. So the period of these is 2 pi over 3, both of them. In other words, one period is going to take place between 0 and 2 pi over 3. Say that again, Alex? Okay. Wasn't it important? I wanted to hear it. Okay. We're going to do a problem right here. I'm going to give you y equals the sine of theta plus pi. I want you to tell me the phase shift of the function. And then I want you to graph it. Okay? So in your groups, I'm going to give you a minute. I want you to discuss what is the phase shift of this function, and then I want you to graph it. Okay? Since this is a plus sign right here, this is really saying theta minus a negative pi, right? That's what that's saying. So really, that's a negative pi. If I take negative pi, c, which is c, divided by k, what's k, everybody? 1. Negative pi divided by 1 is negative pi. So the shift that's going to happen right here is pi units to the left, since it's negative, right? So I'm going to take everything on here and I'm going to shift it left pi units. So right here, this point right here is going to shift over to there. And this point right up here is going to shift, this point right here is going to shift to right there. So the graph is going like this. It moves it to the left.
That's a nice graph.
Okay? Pi units. And that's what it's going to look like. Does that make sense? Any questions on that? It moved everything to the left, pi units. Say that again? No, this is the problem we're doing right here. The blue one is y equals sine of theta. And then the red one is the graph of theta plus pi, which shifts it to the left, negative pi. So everything shifts negative pi to the left. Any questions on that? Okay, next one. Okay, I want you to do this example right here. Y equals the cosine of 2 theta minus pi halves. Y equals the cosine of 2 theta minus pi halves. I want you to find, once again, I want you to find the phase shift of this function. And you're going to have to know the period. Okay, you're going to have to know the period of this function too. So everybody, just right now, figure out the phase shift and the period, and then we're going to stop and talk about that. Yeah. Here, you guys, period equals 2 pi over k. Alex, which one of these is period? I mean, which one of these is k? The 2, because it's 2 times theta. The number being times by theta is the period, is the k. So 2 pi divided by 2, the 2's cancel out, and you get pi. So the period is pi. One cycle is going to take place between 0 and pi. Now, the phase shift, we'll call it PS for phase shift. Phase shift, that's opposite of spaceship, in case you're wondering right there, Alex. Okay, the phase shift is equal to C over K. Do you remember that formula? Alex, you got that formula? Phase shift is C over K. So what's C right here? Well, what is C? Pi over 2. Is it positive pi over 2 or negative pi over 2? It's positive because it's always, it's opposite of that, right? So it's pi halves divided by K, which we already decided was 2. Well, how do you divide pi halves by 2? Yeah, you think of 2 as 2 over 1. Remember, when you have a fraction divided by a fraction, you flip the bottom one over, and you multiply. Pi times 1 is pi. 2 times 2 is 4. So now I have my phase shift as pi fourths, and my period is 2 pi. Now, okay, I'm going to move this right down here. Okay, so now, you guys, we need to graph this. This time, you guys, I am going to say that 1 is right here, 2 is right here. I'm going to make this -1, -2. The reason why is because what's our, oh, we don't have an amplitude. Never mind. Our amplitude's 1, isn't it? But we'll just call it that, okay? And I'm going to make, you know, you can make these anything you want, but I am going to, well, I'm going to do this. I'll go make this pi. We'll make that 2 pi. We'll only go up to 2 pi, though. Negative pi, negative 2 pi. Okay, so my amplitude on this one is only 1. My period is pi. I'm gonna first of all graph this function. Y in green, y equals cosine of 2 theta. Just with the period change. So we know cosine starts up at 1, 0, 1. We know that one period has to take place between 0 and pi. So I have got to go all the way down. So this is going to cross right here. It's going to go all the way down to 1. Cross right back here, and going to go up to 2. That's 1 period. It takes place between 0 and pi, right? I like to do this in, for me to be able to see the phase shift, I like to graph it before it shifts. Okay, that's what it looks like before we shift it. But the period with the period change, right? You guys understand that? Okay, so now the blue one, I'm going to shift it. Which way am I going to shift it? To the right. Pi force, right? So everything, and this is pi force because it's a fourth of pi. Pi is right there, so I just take one of these notches right here. So everything's going to shift over. That's going to shift over there. This one's going to shift over here. The point where it crosses is going to shift right here. Okay, this point's going to shift right to here, this point to here, this point to here, and this point to here. So we're going to go down like this. What if the what? What if the amplitude didn't change? If the amplitude, well, if the amplitude changes, it would be at 0, 2 or 0, 3, whatever the amplitude is.
Does that still make it a cosine function?
Yeah.
It's not at 0, 0.
Well, no, cosine functions start at 0, 1 or 0, 2 or 0, 3. Sine functions start at 0, 0. All sine functions would start at 0, 0 unless you phase shift them.
So is it a sine function? Cosine function?
No, this one doesn't. Well, yeah, this one does start. Yeah, you guys, that's a good question. Can you change? Let me finish drawing this. I can only think of one thing at a time here. Okay, the question is, JD's asking a good question. He's saying, is this now a sine function since it goes through 0, 0? And the answer to that is no. It's a cosine function. We just graphed a cosine function. But can you make a cosine function and a sine function look exactly the same by doing shifts? Because we hadn't done phase shifts yet. So if we haven't done a phase shift yet, then you can tell whether it's a sine or cosine. We're actually going to play a game here next time. It's called Guess the Function. And I'm going to put a function up here. I'm going to put a graph of a function. You guys have to figure out all this stuff right here and get the right function. I'll tell you whether it's a sine or cosine. And you can actually use a sine or a cosine to graph any sine or cosine. If I have a cosine function, I can use a sine. I just have to shift it the right amount. Okay, any questions there? So how many of you think you could graph one of these on your own? I think in your groups you can, so we're going to do one right here. Actually, no, you know what? I'm going to do the vertical shift first, and then we'll put it all together. Okay, vertical shift. We're going to learn about midline. Okay, what is midline? Okay, the vertical shift of a function. If we're given y equals a times the sine of k theta minus c plus h, and y equals a cosine of k theta minus c plus h. What do you think the vertical shift is, you guys, right here? Okay. The vertical shift is h. So the vertical shift equals h, right, Alex? Yep. Vertical shift is h. So the number that's being added, could I put h before it? Could I put h plus a sine? Yeah. I could put the number in front up here, okay? Okay, it's up if h is greater than 0, down if h is less than 0. Okay? So it shifts it up. This is just like the shifts on those other functions that we did. So we should be able to tell whether a function shifts up or down based on that. Okay, now, the midline is y equals h. It's a horizontal line. It's our new x-axis that the function's going to oscillate between. It's going to be the equilibrium point. For example, if I shift a graph down 2 units, let's say I have a graph that's going like this, and that's 1, that's -1, so the amplitude's 1. And I shift it down 2 units, my new equilibrium line, my new midline is what we call it. Instead of being the x-axis, it's going to be down 2 units. And now the graph's going to go like this. Okay? It oscillates back and forth over that midline. Does that make sense? And that line is the line y equals h. So whatever that vertical shift was, that's where it's going to shift to. Any questions there? Okay, I'm going to give you guys a problem, and I expect you guys to get the answers to it. I'll come around and give you hints. I'm not going to do it up here. I expect you guys to get it, because I need you guys to think about this. Some of you guys are kind of spacing off right here. So we got it down? We got all the notes written down? Okay, here's an example. Actually, I'm going to give you one example, and then we're going to do this. One example. Okay, here's our example. Y equals 2 cosine of theta minus 5. Y equals 2 cosine of theta minus 5. Y equals 2 cosine of theta minus 5. I want you guys to graph that. Who would like to come up here and graph it? Let's do that way. Who thinks they could graph this one? Okay. Try it yourself first, and then I'll let you come. Here, I'm going to do this one really quickly. Yeah. You guys, the regular function right here, if this was 2, and this was -2, and this was pi, and this is 2 pi, the period has not changed. Okay, so the regular function is going to go like this. Right? Does everybody see that? We could keep going with it. Okay, that's what the regular function will look like. If we move it down 5 units, 1, 2, 3, 4, 5, here's the new midline. Here's the new midline. I'm going to put that as a solid line. I'm going to dot above it 2, since it has an amplitude of 2, and 2 below it. And all we're going to do is we're going to move this whole thing down 2 units. That one over there should have just gone like that. Okay? And all it did is move down 2 units. Any questions on that? Okay, so do you see how I put the midline down here? And this midline is the equilibrium point. It oscillates back and forth between that midline. It goes 2 above and 2 below. So it goes up to -3 and down to -7 from there. Questions on that? Okay. Now we're going to put it all together. Period, amplitude, phase shift, and vertical shift. All four of those things. And you're going to have to do all four of them. But before I do that, I'm going to give you the steps for graphing. Okay? In fact, I want everybody to turn to page 380 in your book. I'm not going to rewrite them down. Everybody go to page 380. There are 4 steps. It tells you kind of what order to do everything in. I want you to write those down. Number 1 is to determine the vertical shift and graph the midline. So you're going to do the vertical shift. The last thing that we learned is the first thing you're going to draw on there. Then you're going to determine the amplitude. And you're going to use dashed lines to indicate the maximum and minimum values of the function, just like I did on that last problem. The number 3, you're going to determine the period of the function and graph the appropriate sine or cosine curve. And then number 4, you're going to determine the phase shift, and you're going to translate the graph accordingly. Okay? So you're going to follow those 4 steps. Write them down. I'm going to do this in kind of fast. What's step 1? Tell me what step 1 is. Determine the midline. What's the midline going to be on this one? -6, because right here it's going to shift down 6. So I'm going to go down 1, 2, 3, 4, 5, 6. So here is my midline. Okay, so my amplitude is 4, so I go 4 above my midline. 1, 2, 3, 4, and I put a dashed line there. Where else? Okay, 4 below. 1, 2, 3, 4. Okay, there's that line. Then what's the next step?
Period.
The period. Okay, how do I find period? What's K, by the way, you guys? What's K? It's 1/2. Well, there's no 1 there. Why is it 1/2?
Because it's pi theta.
It's theta over 2, which means 1/2 theta, right? What's C? It's not pi. What is it? It's negative pi. Good. Okay, so to find the period, first of all, period is equal to 2 pi over k. So 2 pi over 1/2. If I flip that, what's it going to be? 4 pi. So there's my period. Okay? Now, it says graph it with that period. Okay? So I know it's a cosine function. So it's going to start up here at this point right here, 4 above the midline, right? Because it's positive, and between, and I got to count over, this is going to be pi, this is going to be 2 pi, this is going to be 3 pi, and 4 pi is going to be about right here, right? So one phase takes place between here and there, so it's going to go down like this. It's going to be something like that, right? And I could do the same thing over here. I don't have time to do it. Okay? Now, it's going to shift. It's going to shift. We got to find the phase shift. What's the phase shift going to be? Phase shift. C over K. So C is negative pi over 1/2. If I flip that over, what am I going to get? Negative 2 pi. That means this thing's going to shift. Which way? Left, 2 pi. That means my new function, everything's going to shift. So there's 2 pi. This point right here is going to shift to right there, right?
No.
Left.
-2.
Oh, negative 2 pi. It's going to shift clear over here. You got it. You're right. Okay, so my function's going to go like this. Wherever 1, 2, 3, 4 is. And then 1, 2, 3, 4 right here. Okay? It's going to shift over to the left that much. And there we got it. Okay? Any questions? Okay, there's your assignment right there. Write it down. The bell's going to ring in like 10 seconds. Wow. Are we good or what? We got it all in.